Well, good morning, ladies and gentlemen, and thank you, Mona, for a kind introduction, and thank you, PWI, for having me here today. So picture this. You're on a train, sipping on your morning coffee, reading your newspapers and your emails, and you suddenly hear the announcement saying, delays due to flooding. So in a world where we expect the unexpected, climate change is turning the unexpected into the norm. And despite our best engineering, nature can really surprise us. So our world was built for a climate that no longer exists. Extreme weather events are becoming a global challenge, and not only regional anomalies. We see rain-soaked regions facing relentless storms. We see arid landscapes facing sudden flash floods. So the question is no longer if we need to adapt, because we have to. And also we have to see how can we maintain and protect what we have already built. So during today's presentation, I would like us to have a look at what climate change is. And I'd like, again, bring more emphasis also what Mona said earlier, because it's happening, it's real. Then to see how it is impacting our infrastructure, especially the railway. How can we protect our assets and how to respond in the case of emergency situations? And could we use AI in the future? So now let's take a step back to see what climate change is. So what climate change is it refers to changes in the long-term changes in the global temperatures and other characteristics of the atmosphere. This means global temperature are warming, sea level is rising, polar ice is melting, weather patterns are changing. 2024 was likely the warmest year in 175 years of records. And we can see this from the graphs on the screen, as we all like numbers. And it is clear there is only one trend, and it means it's increasing. So regardless if it's about the global temperature on this side, the sea level on that side of the slide, and those were global info data. And the same for extreme weather events, so storms, flooding, and so on. This data is from Europe, but it could be applied to the whole world. So now I hope it is clear that climate change is happening. And just to give some more demonstrations, in the last year, in the last months, we have heard about a storm or a disaster almost every month, if not even more in 1 month, actually, and all over the world. Another example, if we think at the beginning of this year, so we just finished our winter and spring, and in the first months, we had suddenly days with 25 or plus degrees, and 3 days later, we had snow in most of the countries across Europe, which is not really exactly the norm for these areas. So climate change is happening, and it's not a distant threat. So how it is impacting the infrastructure? So I would like to start with just some short-term impacts, meaning the immediate impacts. In case of a flooding, for example, what's the first thing to happen? Of course, the first thing would be having operation disruption or interruption, actually. So that means the first impact is on the safety of our passengers and on the staff that is on board of the trains. Just imagine having a train that has to be stopped in the middle of nowhere, far from emergency responses. So that's the first big impact. Then, of course, they would have power signal, communication failures, track damage, and all other assets. Then I would like also to give the idea to think also in the long-term impacts, which long-term doesn't mean a lot of years, actually, but could be even just 1 year or 2. So we can have really quick structural damage. Imagine having concrete structures that are exposed to water continuously. Concrete absorbs the water, reinforcement gets corroded, and that means having spalling, so having big areas of spalling, delamination, structural damage, we don't really want to have. Imagine having structural elements, piers and walls that are supporting our constructions. Just to give another example on materials, so materials can get damaged quicker. Just imagine like a sealant on the roof or on outdoors on the glazing. So if this is exposed to higher temperatures than it was designed for, it gets deteriorated quickly. So when a rain is coming, the water penetrates in the buildings, in the stations, so causing more damage. Then, of course, all of these impacts have an economical impact. Weather-related losses were estimated around 360 billion pounds in 2021, which is quite a nice number. And of course, there means also demand and supply impact, damage to economic capital, and interruption of the vital and infrastructure. So moving on, I would like to show you some real examples of what happened around us. So here we are at Pudding Mill Lane Station, the DLR. For those that are not familiar with the station, this is on DLR infrastructure, and this is the street level, and the railway and the platforms are elevated on the viaduct. So in 2021, a very heavy rainfall hit London, causing many disruptions, many stations closed, including Pudding Mill Lane Station. The first thing we see here is obviously the water accumulation, the whirlpools, and actually the first impact in this situation was that passengers couldn't leave the platform, so leave the station, and other passengers couldn't leave the area, so to reaching the platforms and the railway to leave. And this was, again, the first impact is always on our passengers, and so on their safety, and we need to prioritize this. And then what else we can see here is that this water damaged the ticket machines, so it was damage to assets. There's an example of the piers being exposed to water accumulation. And then what we cannot see clearly and directly from this image, it is actually water penetrated in the underground rooms where it impacted electrical equipment that is installed there. So the damages of just a bit of rain or such a water accumulation can reach all assets across an infrastructure. To show a different example, here we are on a viaduct, North Key Delta, and the situation here is a bit different. So it's a very well-designed viaduct, and despite the drainage system being available, the water accumulates in certain areas and kind of a bit difficult to drain it. So if we have frequent rainfall and water accumulation, basically the tracks and the cabling and all the assets are being getting damaged and exposed to the water accumulated. And we know obviously steel and water is not a good match, so something that we should take in consideration. Now, in these slides, we saw that even the base designs can face difficulties, if not failures. So a design that was built beautifully and that worked beautifully for 50 years, nowadays is facing a climate that wasn't built to withstand. So how can we protect what we have already built and maintain what we have? So I would like to start with some examples about temporary solutions. So in case of a flooding, we can maybe have some high-capacity pumps ready to be used and the water tankers ready to be deployed. So in case of a flooding, and unfortunately we cannot avoid that, what can we do to minimize the impact on the operation, on our passengers, and on our assets? So these two solutions could be, let's say, easily prepared. So in the case of a need, can be deployed quickly. Another temporary solutions can be something with more innovation idea is about the flood barriers. So we had different types, 3 different types with the same purpose and different way of installation. If we take, for example, the picture on the top in the corner, these barriers can be easily installed, and for example, can be installed around a full station, so to protect the station in the case there is a heavy rain coming and flooding is expected inside the station. These barriers can protect the station. So then once the forecast improves, the weather improves, obviously this can be removed. Or actually, it makes me think if these would be designed a bit more aesthetically, maybe they can be even a permanent solution, so not only temporary. So we need to think a bit, let's say, out of the box, and how can we protect our assets. Then in case of preventative solutions, first thing, improving and having always a better forecast, just so we can get ready in advance. So for example, if we know well in advance that a heavy rain is coming, we can quickly install the barriers. So it can be left for 2-3 days, and then once the weather gets better, we can go back to normal. Then I want to highlight the importance of having a good drainage system cleaning regime in place. Well, first, let's start from having a good asset portfolio of our drainage system, knowing where we have all the catch pits, the manholes, and drainage channels, and all parts, making sure that this system is working properly, because I don't think we want to have a heavy rainfall and maybe just one catch pit is blocked and it's impacting all the area. So again, I would highlight the importance of having a very good drainage system cleaning regime in place periodically, and not avoid doing this. Then some other solutions could be having underground stormwater storage tanks, which would accumulate the water, and then actually the water could be even reused for other purposes, so thinking about a more sustainable approach. Then moving on solutions for a long term, again, something else that I want to highlight is having a constant and good collaboration between various stakeholders, experts, engineers, infrastructure owners, municipality, because obviously our infrastructure can be used in the urban environment, so we don't want to impact one to each other. Like maybe a manhole overflow is actually impacting the railway. So having good collaboration, it's critical. Then going back to the 2 examples from PWI Lane Station and the viaduct, I was saying about the equipment. So having this equipment elevated instead of on the ground or on the track bed would minimize or actually eliminate the damage to this equipment. So it would be very simple and quick things to implement. So instead of installing the equipment on the ground, just platform elevated. So in case water still accumulates, at least the impact is minimized, if not eliminated. Then maybe thinking some new designs, thinking at having the elevated track sections instead of grade and embankments, just to eliminate the risk of erosion. Then having frequent monitoring of infrastructure and soil movements. We have just seen some better explanation in the previous presentation. So improving and maybe even more frequent monitoring. Is about prevention, so acting in time. Then I was mentioning about some structural damage. So if we would invest in protective coating on these structural elements, again, in case water accumulation is happening, at least our structures are protected. Again, it can be a simple maintenance to do, but the consequences and the improvement would be major. And just to give just another very different example, is about the cable sealing. So if you know the cable pits and the channels where the cabling is passing through, if this is not sealed, if water accumulates in the pits, that water can just use these channels and accumulate in some other rooms or find its way some other places and causing more damage. So again, sometimes it can be very simple maintenance tasks to do, but can have a very big benefit. Now, we saw in this, so of course the best solution would be to avoid having flooding, which is a bit difficult, right? So I would say that then a very important thing is to have very good emergency procedures in place. And this, I can say also from personal experience, just bring awareness to staff, to everybody involved in the maintenance or in design or just dealing with railway. Being prepared that a flooding can happen, an emergency situation can happen. So with having good emergency procedures where we define the roles, we define the training needed, and we prepare response teams that can be quickly deployed with adequate PPE, adequate fleet available in case of a need. So having some emergency welfare available could be having the lights, having some food or some form of food or AC units. Again, because if we keep saying, but climate change is happening, flooding can happen, and so how to react in these situations when something happens. And again, having the dewatering tankers available for deployment or putting some limits, so tracking the water levels, and when it reaches a certain level, we can say, okay, it's time to switch off equipment, or actually it's time to stop the operation and just prevent and put our passengers and staff in safe conditions. And also thinking that something can happen. Could we install something at the stations to provide drinking water supply? Because if people would get stuck, at least water is the main thing that is needed. So thinking how to be ready in case of emergency situations. Now, getting towards the end of my presentation, I would like to mention something about AI as well. So artificial intelligence is getting used more and more nowadays in our daily task almost. So we could actually use AI also for the railway, and because AI could support with predicting flooding and so provide early warning system, then AI could support with water flow management by simulating urban flooding scenarios and optimizing drainage networks. And AI could support with real-time infrastructure monitoring and damage detection. So again, I'd like to highlight that it's important to be proactive and know what to expect so we can react quickly and put our passengers in safe and protect our assets. Now, during my presentation, to just give some examples, and this is just also to make us think that we need to review our risk management, because the risk assessment that was perfect maybe 5-10 years ago, today or in 5 years, it might not be so precise anymore because new threats are coming. So we need to adapt to what is coming nowadays. So now to conclude presentation, I'd like to remind that we saw how climate change can really challenge the unexpected, that even the best designs can face difficulties or failures even, how to respond in case of emergency situations, and let's consider AI if it can be a support for us and getting data, precise data, and in advance. So thank you for your attention.